Let's first review the acid-base properties of a salt solution. The first summary is for the anions that are in the salt solution. So remember that the conjugate bases of strong acids are very weak and therefore will not undergo hydrolysis. They will not hydrolyze water and therefore will not affect pH. A few examples: Cl-, I-, NO3-. But the conjugate bases of weak acids will hydrolyze and will raise the pH by creating excess hydroxide ions. Okay, so remember that if we have something like NO2- in an aqueous solution, it will hydrolyze the water to create the conjugate acid HNO2 and OH-, and the presence of that OH- will raise the pH. Amphoteric anions, those that can act either as acids or bases, will act either acidic or basic based on the Ka and Kb values of the acid and base. So when those problems come up, we simply have to compare them. Here's a summary for the cations. Cations from strong bases are very weak and will not undergo hydrolysis and will not affect pH. So things like those group 1 metals, Na+, Li+, or the heavier group 2 metals, calcium 2+. But the conjugate acids of weak bases will hydrolyze and will lower the pH by creating excess hydrogen ions. So NH4+ or C2H5NH3+. What happens when we have NH4+ in aqueous solution? Well, it donates that proton to the water, creating that excess hydrogen ion. Okay? And finally, small metal cations from weak bases will hydrolyze and lower the pH by creating excess hydrogen ions. The higher the charge on the cation, the greater the effect on the pH. So those small metal cations like iron 2, iron 3, and aluminum will hydrolyze and create excess hydrogen ions.